Screen, right?
Yes, so I think we are live. So first of all, I'm really glad to talk to you, Malcolm, about this very interesting topic. I've been dealing myself with raster data for a long time, and yeah, I mean optimization and visualization of rasters, let alone like I mean getting the value out of it or like doing calculations is still uh, difficult, but at least the basic things as such as visualizations and optimization is also painful for a lot of different use cases. And I think like cog is one of the ways where we can solve this, and I'm really interested into having this conversation with you. uh,
Yeah.
I will just bring your screen. I can see you have added the screens. I'll just bring your screen into the front so that you
Okay.
can start presenting and then you can move forward. I will be off screen, and if you need me, you can just give me a shout out. I will immediately jump in,
Okay.
and yeah, I think we can start. So, all the best. So, I have added your
Yes.
screen,
Thank
and
you.
yeah, bye.
Okay. So, hi everyone. Before I begin, I'll just introduce myself. So, basically, I'm a geologist and a coding enthusiast. So, having said that, I'm presenting to you today the use case of COG. So, I will be presenting it in the most simplest way, which a layman, like a beginner, would be able to implement. Okay. So, that's how I'm going to present it. And I have just highlighted a few topics which I'm going to talk about in this session. These are the topics that I'm going to cover. So let's start with introduction to raster. So as we all know, okay, we are most familiar with Google Maps, right? It shows us satellite imagery. Now, now a simplest example, okay, of a raster would be a photograph that you click with your camera, right? Now, what is a raster exactly? It is a data. It is a basically a data form where the pixels are used to represent data. So here pixels have value, and those values then give it a certain color. Like for example, the image you're seeing on my screen is a true color image. It's a multi-band raster which is displayed as a true color image. Similarly, rasters can be used to represent other kind of data, like for example, heat maps. And nowadays, more and more use cases are happening in the drone sector, where drones can be used to generate very high resolution data and in real time. Okay, so this is a field where even my interests are. We are basically serving drone data to real estate. So I'll start with drone data, and basically to introduce you to drone data before we dive into what the outputs are. Okay. So the technique we employ to gather data is called photogrammetry. And in photogrammetry, what happens is basically it's a technique where we use imagery and build 2D, 3D models from imagery. So the process works something like this. We identify an area which we need to map, and then we prepare a flight plan. So on the left side of my screen, you can see we have prepared a flight plan to map a certain area. Now, these are the lines representing the flight path that the drone will take. So as the drone is flying, as you can see, it will keep on collecting images. So here on the left side diagram, you can see that we have clicked successive imagery. And what this does is this successive imagery is taken such that there is considerable overlap between two successive imagery and also adjacent imagery. So this allows us to match the points between the imagery to give a single scaled map, which we call an orthomosaic. So next I will try to show you what an orthomosaic is. So this is one of the orthomosaic which we have created, and this is where startup is also based. So I like you to appreciate the scale of this. So let me open the real image and show you. So this is a output which is covering the entire campus, about 50,000 square meters. And as I zoom in, you will notice the more I zoom in, the more detail you get. So much that even the tiny saplings that are there planted, you can see. You must be familiar with pipes. You know, these are also very clearly visible. So this is a very high resolution output. Okay. So this is orthomosaic. Now this is a very small area. Okay. We can cover larger areas also. So now what happens there is, as the size get larger, the area gets larger, the file size also increases. So this is the kind of raster data that we generate with drones. So often we have to work with this data, compare it with other data of the site, such as the survey plan of the site, okay, or other vector data which we generate. Or sometimes multiple teams may also be working on this data set. So we encounter certain difficulties when we are working with orthomosaics, which are generally in the TIFF format. Okay, so the challenges are basically, as I said, TIFF format has a very large file size, and if we have to work with this data, we have to first get the entire file, and then only we can start working. If somebody else has to work in parallel, then again we have to give them the entire file, copy the file and give it to them, and then they can work. So basically this leads to inefficiency in our working. And as we know today, we have good internet connectivity, we have access to cloud processing, and we have cloud storage. So we need, so naturally there is a need for a solution which can work in the cloud, can allow us to process the data within the cloud, and that's where the cloud optimized geotiffs come into the picture. So now let's talk about cloud optimized geotiff. So before I speak, if you want to know any more information or detailed information about COG, you can just head over to the site, and here you will find some really good information and documentation about COG. So I will cover some silent points from here in my presentation. So a cloud optimized GeoTIFF is just like a regular GeoTIFF. It has the same extension .tiff, but it is made to be hosted on the cloud and can be easily called via HTTP request into the client. For example, a QGIS desktop application. So this makes COG very interesting data format to work with. And just to highlight some of the main points, we have efficient imagery data access. So any client side application, say QGIS or OpenLayers, can handle this very effectively. Okay, and we can pull the data directly from the cloud. So this improves processing, and we can create workflows. Also, as I mentioned, when multiple people have to work on projects, here we need not copy and give them the file. From the same file stored on the cloud, multiple users can simultaneously access the same file and work together. So this is very interesting. And the third part is, as I mentioned, the cloud optimized GeoTIFF are similar to GeoTIFF in the sense that any older version of QGIS which can also read the COG. There is no compatibility issues because it will be read just like the regular GeoTIFF. So we can use it with older versions of QGIS also, or any other software which can handle regular TIFF data. So just to compare cloud optimized GeoTIFF and GeoTIFF, uh, since handling GeoTIFF, I have realized one thing is, depending on how your data is structured, the COG output sometimes can save anywhere between 20 to 70% of the data. That is, the COG file is having less data as compared to GeoTIFF mostly. But it may also happen that COG file can have more space than geotiff also, depending on how good your data is. But in my experience, I found that a 6 GB geotiff file has been reduced to about 2.5 GB COG file. So this was very interesting, especially because I had a lot of files and I had to combine them together to prepare a base map of a large area. So I experienced a file size reduction of about 40% on the whole. So that was very interesting. And apart from that, as I said, COG can be hosted on the cloud. Therefore, it can be upon by multiple users. And another interesting aspect is uh, you can access a user can access only the part of the data which the user needs. That means the entire file need not be downloaded. You can access the data in only the part which you are interested in. So the rendering is very fast. So now I'll show you how we can convert a regular geotiff into a cloud optimized geotiff. So for most users, okay, who will already have QGIS installed, so this process becomes very easier because as of because the GDAL, okay, comes installed with the QGIS, and very easily we can use the OSGeo shell to directly access the GDAL commands. So I'll show you how you can go about. So if you search for your QGIS installation folder, you can find this, or simply type OSGeo in your search bar, and you will come to the OSGeo cell. So now I have a GeoTIFF already loaded in my C drive, okay, in a folder. And this is the GeoTIFF that I want to convert to a cloud optimized GeoTIFF. So I simply change my directory in the OSGeo cell to this directory. Uh, okay, before that, I just forgot to mention. Uh, for those of you who are having GDAL version 3.1 or later, okay, this can be directly accessed. You can access this command directly from the OSGeo shell. If you are having a GDAL, if your GDAL version is before that, then you'll have to use another command which is listed over here in the developer. If you go here, you will find the GDAL command for the older version. Okay, so since I'm now how to check the GDAL version, you can simply use the command GDAL info dash dash version to know what version you're having. So I just go to my shell, and you can see I am having a version later than 3.1. So I have this GDAL command inbuilt. So uh, let's change directory to the directory where I'm having my geotiff saved on my local system. So I change directory. Now I can use the GDAL command. So here I have already typed the command first only. So here I type the command. So just to elaborate, there are only two inputs here which are necessary. One is the input file name here, which is dbo.tiff, and the output file name. So I just put an underscore cog.tiff for the output file name. So this should work for most of the tips. However, you can add more parameters here. Okay, for example, compression can be changed to different algorithms. Okay, but I found good results with this. However, if you have a very large tip, then you can change this to big tip. So now I'll just go ahead with this one, and I click enter, and now it begins the process of converting my TIFF file into a cloud optimized TIFF file. Now this can take a few minutes depending on the file size. So I assume this is a small file, so I'm assuming this will take a few maybe few seconds, hopefully. So as you can see, while the command is running, already a new file is getting created here in the folder, in the same folder. Yes, done. So now I have two files in my folder, the normal tip file and the COG file. So as I mentioned earlier, we can read these files in QGIS. So I just load the normal geotiff. This is the normal geotiff, and this is the file which we have just created. And you can see here there is hardly any difference between the two. Okay, this is the normal TIFF and the GeoTIFF. However, you may notice the slight change in color because that happens because in the cloud optimized GeoTIFF, any redundant data or redundant pixels that are there, they will be eliminated. So this can also optimize the storage. Okay, but in some cases it can also increase the storage size, but that really depends on what kind of data you are having. So now we need to check whether the new file that was created is actually having the COG structure. Okay. So to check this, there is a command called as GDAL info with your file name. So I want to check whether the new file that I've generated is actually having the structure. So I hit enter, and here I can see image structure layout equal to COG. This means that our newly generated file is having the COG structure. So this file we can now easily host onto the cloud and can be accessed by multiple clients. Okay. So now we will go on to deploy this TIFF file onto our AWS. So for those of you who are not who are new to AWS, there is uh, AWS allows us to host files and create instances on the cloud, and it offers free tier services. So you just need to create an account, and for which you will need a credit card. And once your account is created, you can access the free tier services. So I have already created an account and logged in, and as you can see, it offers various services on the cloud. The one that we need to host our data is S3. So we will use the S3 bucket. So we click on the S3 service, and here you reach this dashboard. Now, as you can see, I have already created one, but for the sake of this demo, I will just show you how you can create a bucket. So once you come to S3 bucket, you can click on create bucket. So here you can assign a name. Okay. So I can assign a name for my bucket. And since we want multiple people to access, from different locations, we can just uncheck this block all public access, and keeping all the settings default. Click on create bucket. Okay, I forgot to acknowledge. So just ensure that you will check this policy, and now we are good to go. Create bucket. Okay, so as you can see, a new bucket has been created. Now we can go into the bucket. Now here we can create multiple folders and store the file, or we can directly upload the file. So it's very easy to upload the file. Just hit upload, uh, click on add files, and now you can upload the COG file. So I'll just click on the select the file and click open, and it will start uploading. So this may take a while, but for the sake of this demo, I have already done this process, so I'll start from there. Okay, so let me go back to my S3 bucket. So as you can see, once your file is completely uploaded, you will be able to see it here in your buckets. Okay, so this is the file that I have just uploaded. Now I'll click on that file, and okay, 1 second. So I enter my bucket. Now, in order to access this file onto my QGIS, okay, now I'll show you how we can access this newly uploaded file in QGIS. So for that, first you need to set the permissions to make this file accessible. So you enter the bucket, click on permissions, and here we need to define the bucket policy. So here I will be sharing this code later. Okay, so I'll just input the code here. So you need to define the bucket policy. So I'll just copy this and paste it here. Okay. When only thing note that when you are doing this for your file, just change this name. You can copy paste your bucket name and insert your bucket name over here, and it should be working fine. So you do save changes. Okay. Now that we have set the permissions for a bucket, now we can go to the particular file, and we can easily extract a URL from here. So just hit copy URL. Now we can open our QGIS application. So let me open new project. So like how we normally add rasters, so we can just go to layer, add raster layer, and here we can say protocol HTTP, and this is where we need to paste the URL, and now we click add. Just wait for a moment. It is so it will connect to the cloud AWS S3 bucket instance, and now it is fetching the data. So as you can see here, the data is being rendered directly from a S3 bucket. Interesting, isn't it? So this allows multiple users to have simultaneous access to a file. As you can see, it will render the same quality of the data. Okay, just that it's taking a little time now because of net connectivity probably, but it's very, yes, it's loaded. So you can see here the data quality is not compromised, and we could do processing, raster data processing, just the normal way. Like you can access the symbology, styling, just like how you would do with a normal raster. So this is how we can easily access our data into the QGIS. Now I will show you next how we can use this in open layers. Now, as you know, open layers is a open source library where we can create our own front end for our web applications. So you can go to openlayers.org to know more. Okay, and you can also access the documentation where there is a quick start guide over here, and if you just copy this code and paste in your code editor, it will automatically configure your application with a OSM map. So now for this part, I have already created the code. Only thing is, once the code is ready, we only need to configure our cloud optimized geotiff, that is configure the link to access the cloud optimized geotiff. So now I'll just show you, if you see the open layers documentation, There are ample of examples how this can be done. So if you just go to examples and hit COG and you click here, and you'll have an example that will render along with the code how it is done. So you can simply copy this code and configure the parameters as per your use case, and you're good to go. So I have already done it over here. Okay, and let me just show you. So this is where we have configured our map, and let me run this code first to show you what we have done. Terminal, new terminal. Okay. So very easily we have created this map, okay, using open layers. As you can see, this is also one of the drone map which we have created, and we are calling some layers, WMS layers, which are external into our application. So you can see this is also high resolution data set. Uh, okay, this is a high resolution data set. Now, just one thing which I forgot to mention. Sometimes when you load this data, there is one more configuration that needs to be done. Okay, that is course setting, cross origin setting. So to do that, uh, you have to go to your bucket permissions, and earlier where we set the bucket policy, here you will find cross origin resource sharing. So here you need to uh, assign the course policy settings. So here I am just pasting it, and you need to edit, paste this here, save changes. So once these course settings are done, then it will easily render the map. So since in my application I'm calling another map, so I already have set the view and all. This would take time otherwise. So I've already configured this. So once you have configured, okay, all that you need to do is change this URL. Uh, sorry, change the URL of the source and set all the parameters like view, projection, and you are good to go. So once these settings are done, you should be able to see your COG loading in open layers. So as you can see, you can build uh, applications like this with your own data, which can be accessed by anyone across the world. So this is a very simple application which I have done just to demonstrate the use cases of COG. So yeah, I think I'm done at this point. If you have any queries, I would love to take. Do let me know. Yeah, Krishna.
Hey, hi Malcolm. Yes.
Yeah. So yeah, so I just so this was a very short demo that I had done, and kept things simple. So yeah, I found this COG to be a very powerful tool for me.
Mhm. Yeah, exactly. Uh, this was actually very interesting to see how exactly we can also work with AWS to store the data and to see things. Yeah, I mean, so there is a question that can you please share the documentation? So, do you have any documentation that you have written yourself that you would like to present, or if you have any
No,
documentation, you can actually share it on the private chat, and I'll put it on the on YouTube chat.
yes. I think I can share the steps for the scripts which are there, right? To check the GDAL info or to check whether the COG layout structure is there, and also to how to set the permissions in AWS. Yeah, and for the front end web application, I think OpenLayers is the best source, and it has really good documentation. Only thing is, depending on your data, what is the extent of your data, you'll have to then customize it. So
Correct.
I'm a coding enthusiast. I was a bit afraid to do it drive directly, so I had already configured it so that we don't get stuck. So
Nice.
I would share all these links, okay, open layers links, COG documentation links, and also the commands that I use in OS GeoShell to the audience so they can get started.
Okay. So if you want, like, you can just create a like a .md file or something like that, and then we'll just post it on our geobharat.github.io under the link. So whoever is watching, probably in like next few hours, I will have the link, and you'll be able to see it on the GeoBharat's talk page for this particular talk. Yeah, I think it was really interesting. Malcolm, this was a really good session. I really appreciate your time. It's I know it's weekend, and you took the time out, so thanks a lot for that. And I hope we will have very soon you here again for another interesting topic.
I hope so. And just I also had a good time, preparing this session for you. And I also, while preparing, I also learned a lot, and I'm continuing to learn. Is For me also, this is something new, but I can see the potential, and that's
Mhm.
that's gotten me excited. And I'm sure there'll be many out there who can also experience this revolution that is happening, uh,
Mm.
the way we can access data so quickly and also build applications out of it which can
Out of it.
have value.
That
Yes,
is,
and it's
that
so
is
easy. Non-coder can do it, and I'm sure non-coder like me can do it, and anyone can do it. A beginner coder can do it. Yes.
true. Yeah. And for the viewers, I would like to let you guys know that there is this native cloud geo, which is one of the foundation which is heavily invested into this. So I'll just put the link in the chat, so anyone can actually refer. They are doing amazing work with the native like cloud native approaches for geo data. So it can be obviously, like, it can be for vector as well as raster data, and cog is like one of the very like one of the things that lot people are now interested. There are so many packages available on various languages to actually create the cog, or to consume the cog in various ways. So again, thanks a lot for taking the time out. And for the viewers, I would like to present our upcoming talks and the schedule about the same. So uh, so we had this amazing talk on reducing the file size, and we have a couple of more talks coming up. And meanwhile, we are also looking for presenters. So if you are watching, and if you're interested, and if you want to share the story that how exactly you're using open source GIS in your particular use case, feel free to reach out either by clicking on here and applying through the form, or you can always DM me on various social media, and on email as well. So yeah, that'll be all from the Geo Bharat side. Thanks a lot. Welcome. Have a good weekend. Thank
Thank
you.
you.
Bye.
Yes, you
Bye.
too. Thank you to all the viewers as well. Thank you. Bye.